Alright, this is part 2 of our review on conic sections. Do not copy off of me. That includes watching 30 seconds of the video and then pausing it and then watching 30 more seconds. You're still basically copying off the video when you guys do that. Just watch the whole video of at least one whole problem without a pencil in your hand, and then go back and do the entire problem yourself. Okay? If you're watching one step and then doing a step and then watching a step and doing a step, you're still just copying off of me and you don't really know what you're doing. Okay, let's get started. Remember, this is part 2. Make sure you did every single problem on part 1 and make sure that you can do it by yourself. Now, we should know what kind of shape this is just by looking at the equation. Alright, for example, I know at a glance that this is an ellipse. Now, here's how I know that. A parabola only has one variable squared. So this has both variables squared, so it's not a parabola. A hyperbola has a minus on one of these squared terms. This doesn't have any minuses, so it's not a hyperbola. If it were a circle, both of these coefficients would be the same, like 4 and 4, or 16 and 16. Since they're different, the only thing left is an ellipse. Okay, so that's what we write down under name. This is an ellipse. Alright. So anyway, we have two squared items, so we're going to have to complete the square twice. So let's group together our square terms. So 16x squared and then plus 32x, okay, and then plus 4y squared and then minus 8y equals 44. Alright, now that's 16 and the 4, we have to factor out these common factors, so I'm going to bring the 16 outside of the parentheses and I will have x squared plus 2x, leave a space. I'm going to bring out the 4 too, so I'm going to have 4 outside the parentheses and then y squared minus 2y, leave a space, is equal to 44. Now, if you have any trouble understanding what goes on the inside, think of it as dividing by the number that you're factoring out. So I'm dividing by 16. Of course, those would cancel out and leave x squared. 32 divided by 16 is 2. And here I'm pulling out a 4, so you could think of it as dividing by 4. Negative 8 divided by 4 is negative 2. Anyway, time to complete the square. So half of this is 1. 1 squared is still 1. Be careful though, I'm not going to add a 1 over here. This is really 16 times 1, which is 16. Similarly over here, half of 2 is 1, and 1 squared is 1. Okay, so I'm going to put a plus 1 right here. But here again, I'm not going to add a 1 over here. This is 4 times 1, which is 4. Okay, so that's what I have. Now, this is going to factor as x plus 1 squared. And this is going to factor as y minus 1 squared. Notice the sign comes from the middle term. The middle term is negative. This will be negative. And then this is going to equal, let's see, 16 plus 4 is 20. So that's 64. Okay. Well, guys, for the model of an ellipse, we need to have a 1 over here. So of course I'm going to go back and divide everything by 64 to get that 1 going. Okay, Now 16 goes into 64 4 times. So this is going to be x plus 1 squared over 4. Alright, and of course it works the other way too. 4 goes into 64 16 times. Alright, so I'll have the 16 and my y minus 1 squared equals 1. So this is the standard form for my ellipse, so I just need to recopy it. So I'm going to have, once again, x plus 1 squared over 4, and then plus y minus 1 squared over 16 equals 1. Alright, there's my standard form equation. Now I am in a position to answer some questions. Okay, I need the center of my ellipse, for example. Well, the center is just going to be the opposite of this and the opposite of that. So -1, comma, +1. So there's my center. And I can go ahead and graph that. -1, 1. So there's my center. Now for the vertices, for an ellipse it's all about whichever one's bigger winds up being the vertices. So my a value is going to come from the 16. Oh, just because that's bigger. So that gives us an a value of 4. Okay. The b value is going to come from the smaller number here, so that's going to give us a b value of 2. Alright, of course this 4 is with the y part of the equation, so that means I'm going to go 4 up and down from the center, of course. Alright, if it's with the y, it's up and down automatically. So I'm going to go up 4 and down 4. So these are my vertices. Okay, I know that because it's the bigger number. But let's write it down. So that's -1, comma 5 and -1, comma -3. Okay, how about those co-vertices? The co-vertices are going to come from this b value, which is with the x's, so we'll do our 2 left and right from the center. So 2 to the left and 2 to the right. So those are the co-vertices. That's -3, comma 1. And it is 1, comma 1. Alright, those are my co-vertices. Now I need the foci. For the foci, I'm going to need the c value. So for ellipses, we know that c squared is equal to a squared minus b squared. Okay, so that means c squared is equal to 16 minus 4. Alright, so that means that c squared is equal to 12. So that means c is equal to 2 radical 3. Which, by the way, is approximately, let's see, we did square root of 12. I missed. Square root, I said. There's my 2 radical 3. And here's the decimal, 3.5. Alright, so the c value is approximately 3.5. That tells me where to graph my foci. The foci will always be in the same direction as the vertices. It will always be the long way. So 3.5 would be, from the center, this is 3, so here's 3.5. Okay, now when I name the foci, I can't use decimals. So look guys, this is one of those things that many students have trouble with. So really focus. Is it the x coordinates or the y coordinates which are obvious and easy? I'm hoping you can see that the x coordinates are very clear. Both of these green foci are on this vertical line at -1. So we know the foci will be -1 comma something. Okay, we know the x value for both points is -1. Now the y value, one is high and one is low. We can't use decimals, so let's start from the center and then go high and low. So if we're starting from the center and we're moving vertically, it's important to look at the what's the y value of the center here. Well, we're starting from a y value of 1 because the center is hovering here at 1. So I'm going to start off by saying 1 plus something to take me to the upper point, and then 1 minus something, all right, will take me to the lower focus. Now, the thing we're adding and subtracting is the c value, because that's the distance to the focus. So I'm adding and subtracting 2 radical 3. So 1 plus 2 radical 3 and 1 minus 2 radical 3. All right, that is how you do the foci. Now the length of the major axis, that's just the distance all the way across the ellipse, the long way. So vertex to vertex, if you will. So that's 4, and that's also, wait, yeah, and that's also 4. So that's a total of 8. All right, the minor axis is the short way, so that's 2 and 2, which is 4. Okay, I think we've given all of the information. All that's left to do is to actually draw the ellipse. I think I'm going to try to cheat, because my ellipses have been pretty ugly lately. Oh, what do you know? A good one. Okay, so your ellipse should look very much like this. Alright, that was it for number 1. Alright, let us move on to number 2. Alright, again, at a glance we should know what this is. Just looking at the 2 squared terms right here, see that minus sign? That tells me that this is a hyperbola. Okay, so let's complete the square. So let's start by grouping together our x values. So I'm going to group this together, and I'm going to have my 16x squared, and then my plus 64x, okay, grouping those x's together. And then I'm going to have my minus 9y squared. Okay, this negative 18 needs to come over and be on this side as well. So I'm going to move it by adding 18y to both sides. Okay, so that will just leave me with the 89. Okay, let's keep going. We cannot complete the square. I'm not going to take half of this and get 32 and then try to square that. I need to factor out the 16. So if I bring the 16 out, then that's going to leave x squared plus 4x. Okay, if you're wondering, I'm dividing by 16. 64 divided by 16 is 4. Alright, and then I will have minus 9. And that's going to leave behind y squared. Now be careful. We're pulling out a negative 9. So what we're doing is dividing by negative 9. Alright, 18 divided by negative 9 is negative 2. So please, please, please make sure you put a negative 2y down. And that's equal to 89. Now let's complete the square. Half of 4 is 2. 2 squared is 4. Now, I am not going to add a 4 over here. This is really 16 times 4, which is 64. Oh, my computer's crashing. Alright, there's my 64. Meanwhile, over here, half of 2 is 1, and 1 squared is 1. But I'm not going to add a 1 over here. This is really negative 9 times 1. Not 9 times 1, negative 9 times 1. So that's, of course, negative 9. Okay, so let's group this stuff together. So this is going to be 16, and this will be x plus 2 squared. Alright, and then I'll have my minus 9, and I will have y minus 1 squared. Notice that the sign comes from the middle term. If the middle is negative, this will be negative. If the middle is positive, this will be positive. Okay, equals. Now, let's just add all this stuff up, my friends. Okay, okay, so I'm just doing 64 plus 89 minus 9. That is 144. So, this is a hyperbola, so we know we need to have 1 over here for standard form. So, I am going to divide everything by 144. Whoops, I fell asleep like in the middle of that problem. I don't have time to go back and check the tape. I hope it was just a microscopic little micro sleep then. If I fell asleep for like a full minute, I apologize. I only got like 1 hour of sleep last night making these videos. Cray cray. Now, let's see. 16 goes into 144, I bet. Yeah, that goes in 9 times. Okay, so that's going to make this become x plus 2 squared over 9. Alright, with that in mind, if 16 goes in to 144 9 times, then that means 9 must go into 144 16 times. That means this is going to be y minus 1 squared over 16 is equal to 1. Okay, let's just copy that down under standard form equation, because that's what it is. X plus 2 squared over 9 minus y minus 1 squared over 16 equals 1. Alright, I know I'm going to start making all kinds of mistakes because I'm just so sleepy. The mistakes are going to happen. Let's get the center going. The center will be the opposite of this and the opposite of that. So that's going to be negative 2 comma 1. And let's go ahead and graph that as well. So negative 2 comma 1. There's my center. Now it's time for my vertices. For a hyperbola, it doesn't matter which one is bigger. Okay, what matters is the one that comes first, the positive one. So we always call that positive one the a value, even if it's smaller. So I'm definitely going to graph this in the x direction because it came from the x part of the equation. So left 3, right 3. So left 3, right 3. Now these are the vertices, okay? Again, if it comes from the first term, the positive term, then it's a vertex. Okay, so the vertices are -5, 1, and 1, 1. Wow, I just fell asleep again. Okay, how long was that? Wow, you guys. Okay, I hope that wasn't very long. Had a little dream just then. I'm not going to tell you what it was. Co-vertices. Okay, so I named those. I am just falling asleep. The co-vertices are going to come from the other number, the one that was not positive. So we'll call that B. So B is 4. So notice this with the y values, which means I'll go up and down with it. So I'm going to go up 4 and down 4, like this. Alright, so those are my co-vertices. That's -2, 5, and -2, -3. Okay, now it's time for the foci. For the foci, we need that C value. Is there any convenient place for me to calculate that? Alright, maybe I'll just squeeze it in right here. Remember, for a hyperbola, the C equation is C squared equals A squared plus B squared. Alright? Your eyes are not fooling you. For ellipses, it used to be minus. But for hyperbolas, it's plus. So let's see. So that means C squared is equal to, alright, and A squared was 9, and B squared was 16. Okay, that means C squared is 25. So that makes this one nice and easy, because C is 5. Okay, now, so I'm going to do my 5 in the same direction as my vertices, always. Okay, so I'm going to go 5 to the right and 5 to the left. And those are my foci. Alright, so I can easily put those down. So it was much more difficult the other time with the radicals and stuff, but this time we got lucky. So it's -7, 1. Okay, and 3, 1. Okay, it's asking for the length of the transverse axis, but that's the distance between the vertices. So that's 3 to the left, 3 to the right, total of 6. Okay, they want to know the asymptotes, man. Well, I guess we need to draw the rectangle. So let's draw our rectangle around the vertices and co-vertices. So your rectangle should be one of these. Okay, so there's my rectangle. The asymptotes are going to be diagonals of this rectangle. Alright, so the asymptotes are going to be like this. Alright, let it stretch out a bit when you do it. Okay, so there's one of my asymptotes. Alright, do the same thing again, the other way. Okay, so there we have our asymptotes. Now we need the equation of these asymptotes, and what I recommend to you is go ahead and use the model that goes y minus y, I guess y minus y1 is equal to the slope times x minus x1. This is called point slope form because all you need is a point and the slope. Let's start with the slope. Alright, we can get the slope easily by looking from the center to the corner of the box. But picture it as a rise and a run. That would be up 4 over 3. So that slope is 4 over 3. Okay, remember that the downward facing one will also be 4 over 3, except for it's negative. Alright, there's always going to be one positive and one negative. Alright, now to capture them both, the positive 4 over 3 and the negative 4 over 3, and save us a step, we can just put plus or minus on here like that. Now for the point that we're going to plug in for x1 and y1, I recommend using the center. Okay, for your center, let this be x1 and let this be y1. Alright, so y1 is 1. So that's why this is going to become y minus 1 is equal to plus or minus 4 over 3 times x minus, now what was that x value? It was negative 2. So I have to switch from negative to addition when I do this. So this will become plus 2. Alright, so this is really two equations, one with a positive and one with a negative. Alright, so you can just leave it just like this. Alright, so those are the asymptotes. Alright, I heard the bell for lunch, so I'm going to have to pause this video right here. So I've done the first two problems so far. So we have a couple more problems that I will do later on. Wait, there's one more thing I almost forgot. I never actually graphed the hyperbola. I did all that work setting up the rectangle and the vertices, the co-vertices, the center, the foci, but then I didn't actually draw the branches, which is kind of the most important part of the graph. So please do not forget to actually draw the graph. So of course I'm going to start from the vertex and I'm going to approach the asymptote. Okay, so it should be doing something basically like this. And it should be doing the same thing over here, getting closer and closer to the asymptote. Okay, and I will do the same thing over here, approaching that asymptote. And one more time. Okay, so your hyperbola should look something very much like this. Alright, so number 3. At a glance, we should know that this is a parabola. Why? Because y is squared, but x is not squared. When only one variable is squared, it's a parabola. Okay, so, and that lets us know that we are shooting for this type of equation. And plus I noticed that the y is squared, so for my standard equation I'm thinking like this. Y minus k squared is equal to 4p times x minus h. This is the shape that we're looking for. So notice that we have a binomial squared on the left. We do have parentheses on the right. Alright, we have y's on the left, x's on the right. Kind of keeping this in mind helps guide our actions. So the y's need to wind up on the left because they're squared. Alright, everything else needs to wind up on the right. So the 8x, the 8, all that has to go to the right. So yeah, I'm going to, subtract 8x and subtract 8 from both sides. Okay, so that is going to leave me with my y squared minus 8y. Leave a space. Alright, and that's going to equal negative 8x minus 8 over here. Now, this is the part where you complete the square. Half of 8 is 4. 4 squared is 16. So I'm going to add 16 over here. And to balance it out, I will add 16 over here as well. There is no coefficient that I have to distribute, so it's just 16 on both sides. When I complete the square, alright, because this is going to factor down as y minus 4 twice. Okay, you know how it is. Meanwhile, over here I've got negative 8x. Combining these like tisms, I'm going to have plus 8. Alright, 16 minus 8 is 8. But I can put this together as y minus 4 quantity squared equals. Now, remember we need parentheses over here as well. We're going to get that by factoring out this a common factor of negative 8. So I'm going to bring the negative 8 out. And that's going to leave on the inside x minus 1. Again, if you have any confusion about that whatsoever, understand that when we factor something out, we are dividing. So I'm dividing by negative 8. And you can see positive 8 divided by negative 8 is negative 1. So look guys, this is standard form. Oh, by the way, I forgot to write it down, parabola. So we can fill this stuff in now. Okay, so it was y minus 4 and negative 8 times x minus 1. Okay, so at a glance, we should know what the vertex is. The vertex is going to be the opposite of this and the opposite of that. Be careful, obviously we still want the x coordinate to come from the x part of this equation. So I'm going to start by doing the opposite of this and putting a 1, alright, first, x. And then the y, of course, comes second. So it would be 1, 4, opposite, opposite. So there's my vertex. Let's go ahead and graph that. 1, 4 is right there. Now before I go any further, guys, does this open up, down, left, or right? Well, I see that I have y squared. When it's y squared, that means it's one of those sideways parabolas. So it will either be left or right. And because of the negative on this 8, I know that this is going to open up to the left. Okay, so just keep that in the back of your mind. This parabola opens left. Okay, so it's time for the focus. Now for the focus, I'm going to need the p-value. Hopefully you know that 4p equals this negative 8 right here. If I divide both sides by 4, I get p is equal to negative 2. So that's useful. This tells me where to put the focus. I knew I would go to the left. Now I know I will go to the left 2 from the vertex. So here's my vertex. If I go left 2, this is my focus. It also tells me where the directrix will be, because it should be the same amount in the opposite direction. Okay. So I'm going to have a directrix like this. Alright, so it's 2 to the left, so 2 to the right, directrix. Okay, that's a fail. Alright. Wow, okay. Still a fail. Alright, let me start over. Okay, there's my directrix. Should I make it darker? Well, that's better. Okay, what else do I need? So, vertical lines are always x equals something, so that's x equals 3. Did I forget to write down what the focus was? The focus, the green dot here, is -1, comma 4. Okay, the focal width, man. The focal width comes from this number right here in the front. Alright, the focal width is always positive though, so we're just going to call it 8. That will allow me to place a couple extra points on this graph. If I know that the focal width is 8, that means the width of the parabola, alright, which is going like this, the width at the focus is 8. I can achieve that if I go up 4 and down 4, if that's how wide it is. So you'll see that's a total of 8. So that's enough to show me how the parabola looks. Wow, I'm having a really hard time drawing this thing today. Alright, whatever comes next, I'm just going with it. I'm just going to stick with it no matter what, because I don't have time for this. Okay, and the other one's going to be doing that kind of a thing. Okay, yeah, good enough. So there it is. That is what your parabola should be looking like. That was number 3. I think I got everything. Alright, number 4. At a glance, I know this is a circle. I know that because both of these are squared, it's positive, and the coefficients are the same. Well, 1 and 1. So this is definitely a circle. Okay, and we know the standard form equation of a circle is it's x minus h squared plus y minus k squared is equal to the radius squared. So this is the shape that we are shooting for. To achieve that, we are going to have to complete the square twice. Okay, so grouping the x's together, I'm going to have x squared plus 6x, leave a space, and I'll have y squared. There's no y to go with it. That's fine. But the 17 is going to have to go over there by itself. Alright, because I added 17 to both sides. So I take it back. I'm only going to have to complete the square once. It's a weird circle. So completing the square, half of 6 is 3, 3 squared is 9. Alright, got to do that to both sides. Alright, this allows us to rewrite this as x plus 3 squared, and then plus our y squared is equal to 26. Now, this is the standard form for this circle. This is the standard form equation. So I'm just going to recopy it down here. Now, from this, we can tell the center. It's the opposite of this and the opposite of this. Now, this y squared is just like y plus 0. So we're going to get a 0 out of that. So negative 3 comma 0 is the center. And we can go ahead and graph that as well. So negative 3 comma 0, there's my center. Now the radius, remember that this is the radius squared. So the radius squared is 26. That means the radius is the square root of 26. Now, this doesn't reduce, but I can tell you that it is approximately 5.1. Okay, that means I will land on the circle if I go 5.1 in all directions. So 1, 2, 3, 4, 5. Okay, 5.1. All right, 3, 5.1, and 5.1. So you can see where the circle sits. Okay, and that is the end of that. Oh, I guess we should write down the radius. The radius was square root of 26. Don't use the decimal, use the radical. Okay, that's it for number 4. Number 5. All right, I think this is the last problem. Write the standard form equation of the hyperbola with these asymptotes. Okay, well, considering how we often do, we can get the center from this, all right, following the pattern that we've done many times. So if the center is going to be the opposite of this and the opposite of that, so we can say that the center will be -8, 5. So there's my center. Okay, also, if you picture this as part of a rectangle, okay, you know those rectangles that we always have when we're graphing a hyperbola. Okay, and imagine that this is the center, okay, and then you got your diagonal that's going like this. Okay, this 6/7 is like the rise and the run, so it's like up 6/7. So the important part is the 6 is in the y direction, and the 7 is in the x direction. Okay, and why that's important is it's going to be like having your A and your B. So when you go to make your equation, watch how easy this is. It's a hyperbola, so we know it'll be minus fraction fraction equals 1. Okay, if we know this is the center, then we can just do x plus 8. All right, I'm just doing opposites, and then squared. Don't forget the squared. And then I will have y minus 5, and that's squared. We don't have enough information to know if it should be the x's first or the y's first, so you can just do whatever you want. But we know that the 6 is a y, okay, so it needs to go with the y's. Of course, this is like an a or a b, and here we need a squared or b squared, so this would be 36, but remember, this is rise over run, so this number is always going to be a y value, so it goes with the y's. The 7 is an x, so it goes with the x's. So this is going to be 49. So this is one solid equation that you could use. Okay, now if you had these terms the other way around, with the y's first and the x's second, that would be equally good and valid. All right, and that's but that's it. That's how you do it. Maybe you notice that I went uphill, and this is clearly a downhill thing, but you know how it is. Normally we just do plus or minus anyway, so it really doesn't matter. Just rise over run. Alright, that is it for this review and this video. Remember that this was part 2. And please go back and make sure you can do every single problem on this part and the last part by yourself. I will see you on the next video. Good luck out there.